Okay, for this page, we have 4 different equations, and the main thing is that we need to first determine which form is it in. We have vertex form, which is f of x equals a times x minus h squared plus k. Standard form, which is ax squared plus bx plus c. We have intercept form, which is a times x minus p times x minus q. So these are kind of the 3 different forms that we have for our equations. And I'm looking at this first one. It looks to me like it's in vertex form because I would have my a here and then x minus h squared plus k. So that looks like vertex form to me. So that tells me I don't need to fill in the information for standard form or intercept form. A in this case is 2, h is 4 because whatever's on the inside of parentheses is the opposite. So if it's x minus 4 is going to be a positive 4, k is going to be 5. When we are in vertex form, the vertex is very simple. It's just h and k. That is the vertex. So for this one, 4, 5 would be the vertex because that is h and k. For the axis of symmetry, that is always the x value for the vertex. So we're going to have x equals the x value for the vertex in this case is 4. You get that from h from the equation. The y-intercept is a point that is always going to have 0 as the x value, but then we need to find the y value. So I'm going to do that by substituting in 0 for the function. So if we have 2 times x minus 4 squared plus 5, I'm going to substitute in 0 for x, and that gives me 2 times 0 minus 4 squared plus 5. 0 minus 4 is negative 4, so that would give me 2 times negative 4 squared plus 5. Negative 4 is negative 4 squared is 16. That's going to give me 2 times 16 plus 5. 2 times 16 is 32, and plus 5 would give me 37. So my y-intercept is 0, 37. And again, I find that by substituting in 0 for x. And our x-intercepts we only need to find if we're in intercept form, but this one is not. This one's in vertex form, so we don't need to do this one. So on to the next one. I have y equals x plus 2 times x minus 6. This to me looks like it would be in intercept form. I don't really have anything for a. A would just be 1 in this case. So we are in intercept form. A is going to be 1. But I do have something that looks kind of like x minus p and x minus q. Now we have these 2 pairs of parentheses. Remember, that's whatever's on the inside of the parentheses is the opposite. So if we have x plus 2, and p here would be negative 2, and we have x minus 6, so q is going to be a positive 6. To find the vertex, the first thing we need to do is find p plus q divided by 2. P plus q divided by 2. So for this case, it would be negative 2 plus 6 divided by 2, which gives me 2. So the x value for my vertex is going to be 2. Then I need to substitute that into the function for x. So I'm going to have 2 plus 2 times 2 minus 6. That's going to give me 4 times negative 4. And 4 times negative 4 is negative 16. So 2 and negative 16 will be my vertex for this function. For the axis of symmetry, Again, the axis of symmetry is always just x equals the x value of the vertex. So our vertex was 2, -2, -16. So my axis of symmetry is going to be x equals 2. For the y-intercept, once again, it's going to be a point where 0 is my x value, and then I need to find the y value. I can do that by substituting in 0. So that'll give me 0 plus 2 times 0 minus 6. 0 plus 2 is 2. 0 minus 6 is negative 6. 2 times negative 6 is negative 12. So 0, negative 12 is my y-intercept. And I don't need to find the x-intercept. Oh wait, I do need to find the x-intercepts because we're in intercept form. So the intercepts, when we're in intercept form, are the points P0 and Q0. So in this case, P is negative 2, so that'll give me negative 2, 0. And Q is 6, so that's going to give me the point 6, 0. So negative 2, 0 and 6, 0 are my two x-intercepts for this problem, for this equation. Okay, on to the next function. We have 2x squared minus 4x plus 5. That to me looks like it would be standard form, because we have ax squared plus bx plus c. So that looks like it kind of matches up to me, where my a would be 2, b would be negative 4, and c would be 5. All of these are just kind of exactly what we see because none of them are inside of parentheses. So we have a positive 2, a negative 4, and a positive 5. For the vertex in standard form, the x value of the vertex is found by taking negative b divided by 2 times a. So in this case, this would be negative, b is negative 4, divided by 2 times a is 2. Negative 4 will give me a positive 4, and 2 times 2 is also a positive 4. So 4 divided by 4 gives me 1 for the x value for my vertex. Then we're going to substitute that back into the function. 2 times 1 squared minus 4 times 1 plus 5. 2 times 1 squared would be 2, minus 4 times 1 would be minus 4, plus 5. And that's going to give me 2 minus 4 plus 5 will give me 3. So 1, 3 is my vertex. Once again, the axis of symmetry is going to be the x value of the vertex. So if this is 1, then we're going to have x equals 1. And also again, for the y-intercept, we're always going to have 0 for the x value and then substitute it into the function to find the y value. So here we would have 2 times 0 squared minus 4 times 0 plus 5. Well, 2 times 0 squared is going to be 0. Minus 4 times 0 would be plus 0. And plus 5 is going to give me 5. And here we could also have remembered that for standard form, the y-intercept is always the point 0, c. Right, c, or 5 was our c in this case. So if you have it in standard form, then our y-intercept is 0, c. In this case, it would be 0, 5. And since we're not in intercept form, we don't need to find the x-intercepts. Right, we got one more equation on this page. So that is this one, x minus 7 squared. This one may be kind of hard to tell which form it's in. You could make a case that it's in a couple of different ones, but I think this is probably closest to vertex form, where we would have an a times x minus h squared plus k. But I don't see a number for a, so that would be 1. I don't see a number for k, so that would be 0. But I do see an h in the inside of the parentheses. It's going to be the opposite of that x minus 7. It will give me a positive 7. So this is what I would say this equation is in. For the vertex in vertex form, remember the vertex is hk, so for this case it would be 7, 0. And that's h and k. For the axis of symmetry, once again, it's going to be the x value of your vertex, so x equals 7 in this case. And for the y-intercept, it's going to be a point where x is 0. Substitute in 0 to the function. We're going to have 0 minus 7 squared. That would be negative 7 squared, which is 49. So 0, 49 is the y-intercept, and we don't need to find the x-intercepts. So I know that was a lot. Make sure you've got those written down. You don't necessarily need to have all of the steps written. You just need to have the points in each box. So you need to have the point or the equation in each box, not necessarily the rest of the work. But hopefully you have a good understanding of how to do these problems, so that way you can do them on the test.